Hello everybody, this is Dr. Nageswara Rao, Assistant Professor of Physics, SRR and CVR Government Degree College, Autonomous, Visakhapatnam. We know digital electronics is one of the main branch for the present computer era. Without digital electronics, we cannot construct any computer or any digital equipment. So for the construction of these computer equipment, the hardware contains different logic gates. Logic gates are electronic building blocks in which there are different. We have one of the logic gate is OR gate. Today, in our presentation, we will discuss about OR gate. Logic gates is nothing but it is electronic building blocks and it is the system and it is an electronic circuit. It contains one or two or more inputs and only one output. These logic gates are having relation between input output and we have these logic gates are two types. One is combinational logic gates and the second one is sequential logic gates. Combinational logic gates is nothing but the output of any gate is depending on the input of that at that time only. It is nothing but the output is always depending on the inputs at any instant of time. These gates are called combinational logic gates. It is nothing but these outputs is not depending on the previous inputs. Examples of these combinational logic gates are OR gate, AND gate, NOT gate, NOR gate, NAND gate, exclusive OR gate, and exclusive NOR gate. These logic gates having different properties and different applications in the hardware of all computers and memory cards. And the second one is called sequential logic gates, in which the output is depending on the previous inputs also. I also said that order sequence of the inputs applied to such gates. These are called sequential logic gates. Some of the examples of sequential logic gates are flip-flops, registers, counters, etc. Actually, what is flip-flop? We know nowadays we are using memory cards. Each flip-flop is called memory element. Each flip-flop can store information in binary digits, either 0 or 1. Similarly, registers and counters having different applications. Now, today, actually, we will discuss about this, one of the logic gate, that is OR gate. OR gate contains also two or more inputs and only one output. And the output is equal to sum of the two or more inputs, what we have in that logic gate. The principle behind this OR gate is, if any one of the input is 1, the output is 1. Or if any one of the input is maximum, the output is maximum. How it is possible? There is only if it is addition is possible. For example, 0 plus 1, 1. 1 plus 0 is 1. And in this case, 1 plus 1 is also 1. This is nothing but where 1 is nothing but high. 0 is nothing but low. Not 1 is numeral or 0 is numeral. The OR gate having, if there is a two inputs A and B, then the output can be written as X is equal to A plus B. So that OR gate it can be represented by addition. So if we remember, OR gate is addition, the understanding this OR gate is very easy. So that if two inputs are A and B, then the output X is equal to A plus B. If there are three inputs, the output X is equal to A plus B plus C. Simple. In this manner, we can sum any number of inputs. The symbol of this OR gate is this one, where there is a two inputs A and B, and the output Y is equal to A plus B. So truth table. Actually, if there is a two input we have, for example, in this truth table, the output is same as like this. There is a two inputs is nothing but A and B. We know in binary number system, there is only 0 and 1 is possible. So there is two inputs is nothing but 2 square. That is 4 combinations we have. That is 0, 0, 0, 1, 1, 0, and 1, 1. So OR gate is nothing but the output is we know x is equal to A plus B. So that 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. And 1 plus 1 is 1 here. Actually, in mathematics, we can represent that 1 plus 1 is 2. But here in logic gates, 1 is nothing but high. High plus high is always high. This is the truth table of the OR gate. These OR gate can construct in different methods by using electrical equipment, by using electronic equipment also. So, by using the electrical equivalent circuit of this OR gate is shown in this figure. This is battery. There is a two switches A and B. That is nothing but inputs. This is one bulb is connected in series start one. The bulb shows the output. For example, in the first case, combination A is equal to 0 and B is equal to 0. That is nothing but if A is open and B is open. When we observe this diagram, when A is open, B is open, the circuit is not completed because there is at A is open and B is open. Circuit is not completed is nothing but current cannot flow through the bulb, so bulb does not glow. Bulb does not glow is nothing but the output is 0. That is shown here. X is equal to 0 shows that the bulb does not glow. And in the second case, if A is equal to 0 is nothing but F is A is open and B is 1, that is nothing but B is closed. Then what happens? B is closed is nothing but the circuit is completed like this. So the current will flow from battery to through A, B switch 2 and bulb A, bulb X. So the circuit is completed and hence the bulb glows. So that if A is equal to 0 and B is equal to 1, the output is 1 because bulb glows. Similarly, in case 3, if A is equal to 1, that is nothing but A is closed, switch A is closed, and B is 0, that is nothing but B is open. Then the circuit is completed. The current now passes through the switch A because the cover connection is like this, that is switch is closed. So the current now also passes through the bulb and hence bulb glows. Bulb glows is nothing but the output is 1. And the final condition is nothing but if A is equal to 1, that is A is closed, and B is equal to 1, that is B switch is also closed. Then what happens? So both the switches are closed, the current will flow through the two switches and the total current will flow through the bulb and bulb glows. So in such case also the bulb glow, it shows the 1. So this is the analysis of the electrical equivalent circuit of OR gate. Similarly, we can construct an electronic equivalent circuit to the OR gate by using two junction diodes. This is a junction diode D1 and this is junction diode D2. We know this is a p-type semiconductor. This is n-type semiconductor. In here also, this is the junction diode D2. This is a p-type semiconductor and this is n-type semiconductor. So all p-type semiconductors are connected to the two batteries. Those are represented by A and B. And the output is taken from the n-type semiconductor. So this is the output. This is where load resistance or L is connected to the ground. Now, how can we explain this? It acts as a OR gate. If A is equal to 0 and B is equal to 0 is nothing but this is 0 voltage. And here B is also 0 voltage. In such cases, diode junction diode D1 and junction diode D2 both are in reverse bias. We know because reverse bias is nothing but there is no current flowing through the junction diode. There is no current at junction diode D1 and there is no current flow through junction diode D2. So there is no current passes through the load output RL and the output X is equal to 0. This shows the X is equal to 0. And the second case, if A is equal to 0, that is nothing but this A is 0. A voltage is 0 and B is equal to 1 is nothing but it may be shown as 5 volt. Then according to this diagram, diode D1 is in reverse bias so that there is no current passes through the diode D1. But diode D2 is in forward bias because P-type semiconductor is connected to the positive terminal of the battery and N-type semiconductor is connected to the negative terminal of the battery or to the ground. Now diode D2 is in forward bias and hence the current will flow through the junction diode D2. Now the current will pass through the output. So along this character will flow so that output X is equal to maximum so that X is equal to shows 1. Similarly in third case, if A is equal to 1, that is nothing but A contains 5 volts and B is equal to 0, that is nothing but B output input is 0. Now diode D1 is in forward bias and diode D2 in reverse bias. Diode D2 reverse bias is nothing but there is no current passes through the junction diode D2. But diode D1 is in forward bias, so the current will pass through the junction diode D1 and the current which is passing through the load resistance RL. So the output current is there at X. So the third case, X is equal to 1. And the final case, if A is equal to 1 and B is equal to 1, is nothing but A is equal to 5 volt and B is also 5 volt. Then both the diodes in forward bias. So current will flow through the load resistance RL. So the output is maximum. So that X is equal to shows 1. So this is so that we through the table of the R gate exactly replacement by using this electronic device. So this is called equivalent electronic circuit of the R gate. So these are the examples shows the verification of truth table of R gate. Thank you.